battery inside your mobile, they will resist some amount of voltage. Okay, if you are not charging your battery for so long, if it's completely 0% of charging and you are not even charging your battery for 1 week, 10 days, or maybe 2 3 months, then what happened due to self discharging capability? So this cells battery is having a self discharge. Okay, due to the self discharge capability problem, they will completely going to be dead. Other one is a continuous load current. So how much of continuous it can able to provide the amount of current. So in the cells, it's measuring in the milliamperes, maximum, average, and minimum. They will specify in your data sheet of the cells. Okay. Intermittent load or maybe second pulse load. Like we are giving the acceleration, sudden acceleration, brakes. So they will. We need to look that when you are giving the sudden loads, pulse loads. So how much of current it can capable. Okay. Maximum current or minimum current, average current. On-off conditions. So number of on-off is called the life cycle of the battery. So this cycle here I mentioned. So life cycle of the battery is nothing but a, we can say number of cycles of the battery. It will display like a 15,000 or 20,000. Okay, that's why the companies, most of the companies, they say that we will give that 5 years of warranty, 10 years of battery replacement warranty. That is depends on this life cycles of the battery mainly. Okay. Here one life cycle is nothing but we are charging from 0 to 100 and again discharging from 100 to 0. That is called the one cycle. Okay. And the storage period. As I told you, one more point, like this battery is having a self-discharge some disadvantage. So lithium batteries, if you are not using for a long time without any utilize, right? So the auxiliary power supplies are maybe some future, some function will be there. Okay, I cannot exactly we can say specific this function. So the hundreds of functions are there, and as well as due to self-discharge capability, what happened? This is going to be dead if you are not using your mobile. You can take if nowadays uh, you can observe in your mobiles also. You are not going to be using your mobile phone anything. Okay, you just charge your mobile for 100% and keep it aside. Right after maybe 5 hours or 6 hours, you can observe that at least 2 to 3% of the amount of your percentage of charging will be reduced, right? So that is called the storage period. Okay, so each battery having their specified the storage period. Without utilizing their storage period, if you're keeping for a long time, the battery may be chances of the dead. Okay, you can't recharge again. So that's why you need to check that how much of time period you can be store the battery without any utilization. Okay, so charging and discharging. So this will play the crucial role here also. So what is your charging time? So charge from 0 to 100%, how much of time is taking? And what is the charging temperature? So how much of your battery can withstand? As we said in the starting, so we have different types of charging, no, slow charging, normal charging, and fast charging. Whenever you're going to charging your batteries, there is a amount of heat is also going to produce. Okay, those things maybe you can also observe in your mobile phones. When you're connecting a fast charger to your mobile, sometimes there is a heat is going to generate. Some mobiles are heating very high. Okay, due to this. So when you are going for this, mobile is a very small electronic equipment. If that is producing that much of heat, let us assume how much of heat is produced by the EV batteries, right? So we need to careful that how much of heat is going to temperature is heat is and temperature it's producing or it's capable to withstand in the conditions. Okay, and the temperature and humidity. So at what is the temperature and humidity it can be stored and it can be utilized. Why this is important? The ambient temperatures and storage temperature. If you go to the different countries having different temperature. In India, we have a different three seasons: in summer, rainy, winter. We have different atmosphere. If you go to the Dubai or Gulf countries, the temperature is very high. It's more than always 35 to 40 is minimum you'll there. Sometimes it will hit the 50 for 60 also. Right. Inside the vehicle, if you are using the electric vehicle, right, the heat will be generated nearly 70 to 80%, 80 degrees centigrades. Okay. So that's why what is the ambient temperature and humidity can be withstand. If you go to the cold countries like European countries, the temperature is very low. We know that the battery operation or the electron flow will be low if the temperature is very low. You can observe those things. So if you are in your home, there is an inverter. Okay, in the winter season, the charging is going to be little bit slow. Okay, right, this is called the electrode denaturation formation system. Right, there's a white solid is going to forming on the batteries. And the dimensions and shape. So height, weight, length, all mass and shapes. Why this is important? So whatever the vehicle you are battery you are making for the particular vehicle, as a two wheeler or four wheeler or eight wheeler, right? That need to be fit inside the vehicle, right? Right. It should not be like you're taking the one battery itself is a some very big size and you want to fix it, but the capacity is not meeting. Then what we need to do? We need to set the battery according to your vehicle requirement. What is if the cell is very small size but its capacity is very high, then it is very useful. Okay, if suppose the cell size itself is very big but its capacity is very low, if, to make a 1 4 kilowatt or 2 kilowatt of battery, we require the thousands of cells. There is no space for other equipment, right? So that's why we need to check the dimensions and the mass of the vehicle. So mass is also important. Why? Because you can see generally maybe in two wheeler or four wheeler also you can observe, if one person is driving the vehicle speed, we can go to acceleration very high and you will get more mileage, right? If three persons are sitting on the bike, or the 6 7 8 people are sitting inside the car, right, the capability of the dragging or the transmission system, right, vehicle is going to reduce. It will give less mileage, right? If your vehicle battery itself is consuming 50% of the mass, what happen? Remaining others equipment, tires, transmission, other things also going to consuming some weight. So your battery should be less weight, small size, right, and fit into your specified space in the vehicle. Okay, if you are keeping in below the passenger seat or below the driver seat or inside backside of the uh, car or front of the car, based upon the dimensions need to fit. Okay. So some other factors also we need to look into that when you're selecting a batteries. So atmospheric pressure, so how much of pressure it can be withstand. What is the mechanical conditions? That means it can withstand for when it's hitting for the some stone or vehicle damage during that. How much can we withstand? What is the mechanical state and condition? We need to look into that. And safety, like the caps, so positive, negative caps and seal, whatever a seal is there, that also need to be very serious requirement. Okay, if the packing is not properly, then what happen? Easily there may be chance of the breaking, right? That's why we always need to be take care of that. What is the safety level? So what safety level they are followed as per the industry standards and this, right? Interchangeability, marketability, price. So these are like suppose if there is any problem happen inside your battery, okay, so it need to be replaceable. Okay, and that must be available in the market. If you are buying the vehicle today and the tomorrow this cells are not available in the market, if any problem will come, then you cannot able to replace it, right? If you are not able to replace it, that means entire battery itself is going to be wasted. Okay, as we know that the for 50 to 60% of the cost of the EV itself is battery, right? If you are some other company batteries market is not available in the market, that same particular cell is not available, and you got a only the hundreds of cell, one cell is going to damage it, right? So if you are not replacing, the entire battery is going to affect it. So that you also need to check that. So it is a interchangeable, I mean replaceable or not. It is available in the market. If you are purchasing today and tomorrow it will be not available, it's going to be issue. And the price. So what is the price? So in the starting itself we discussed, right? So price is going to playing an important role to replace the IC engines in the electric vehicle. So that's why our battery, the 40 50% cost is also the overall EV. The battery itself is a 40 50%, right? So we need to reduce that price. So how much we will reduce, that much of EV is going to be success, right? Uh, these are some basic things I would like to know. I told you like there are different types of batteries. One is called the primary batteries and secondary batteries. So primary batteries is nothing but which we are using in our remotes, our torch lights. So is consisting, which is not rechargeable, which is coming with fully chargeable batteries. So whatever the life they will specify, that much of time we can use it, then we need to throw it and replace a new one. Okay, that is called the primary batteries. We are not going much in detail here. Maybe you are all aware. And the secondary batteries is called the rechargeable batteries. So which is consisting of one anode, cathode, and a separator with the electrodes. Okay. During a charging, what happened? The electrons is flowing from the cathode to anode, and during a discharging, the electrons is flowing from the anode to cathode. Different types of batteries, recharge batteries, as I told you. So we have fuel cell technology, lithium ion batteries, ELDC, lithium ion capacitor. Right. So this eigenplots shows the energy versus power density. Right. So why this is important? So how much of energy and power is there? If there is a high power density, that means it can be able to produce a more amount of power. But how much of space is taking? That is called energy density. With a small space, if you are capable to store the more power, then it is the best cell. In that, so as of now in the market, the fuel cell having a slow, high energy density, but the power density is less compared to the lithium ion or nickel metal or lead acid batteries. Okay, so there are some cell chemistries which are available in the market for the two-wheeler or four-wheeler segments are heavy lead acid batteries, nickel cadmium, nickel metal, lithium ion, sodium sulfate, redox flow batteries. So redox flow batteries generally we are using in the inverters, not in the vehicles. So remaining batteries we are using in the electric vehicles or any IC engines or some of the vehicles we are using. So these are one small comparison. So in the different factors, so energy density, internal resistance, life cycle, charging time, overall tolerance, self-discharge. So energy density is nothing but how much of energy it can be withstand per kg. How much of watt hour per kg it can capable to produce per cell. Okay. In that cases, so which are available nickel cadmium, nickel metal hybrid, lead acid, lithium ion, and lithium polymer batteries. So in that lithium ion having a high energy density compared to the other batteries. Okay. So the internal resistance in the milliohms, right? So internal resistance is nothing but so what are the material we will use inside the battery? It's having a some resistance characteristics. Okay, due to that resistance characteristics, what happen? The amount of power self discharge itself is going to be wasting. Okay, that means for if you take in the 12 volts of battery pack, so the resistance will be the nearly to less than 100 milliohms for the lead acid battery. When you go for the lithium ion batteries or lithium polymer batteries, there is for 7.2 volts battery itself is there is a 100 to 150 to 200 milliohms of resistance. Because of that, the charging, if you are not using it itself, it's going to be discharged. Yeah, please. Anyone having any doubt? Okay, the life cycles. So to the 80% of the initial capacity, if you are taking, so the life cycles, number of life cycles of the battery. So nickel cadmium having a highest life cycle compared to the other cells, which is nearly 1500. And fast charging is nothing but fast charging time is nothing but so how fast you can charge from 0 to 100%. It's typically 1 hour for the nickel cadmium. So whichever is highlighted, that is the best results providing. So overall tolerance. The lead acid battery is having a high tolerance charging and self-discharge per month at room temperature. As I told you, without utilizing the battery, if you are keep it aside, your vehicle or battery, so 5% of its capacity is going to be lost due to the self-discharge per month. Whereas other batteries nearly 10%, 20 and 30%. Okay. And the nominal voltage also, if you can see, the lithium batteries having nominal voltage is very high, right? And the load current as a peak current are the best results. You'll get the 2C or 10C. This C is nothing but the capacity terms, right? So 1C is nothing but suppose your battery capacity is like a 1500 milliampere per hour. Okay. If you are discharging 1500 milliampere per hour, then we can say it is a 1C, right? If you are increasing the load 20 times, that means you are discharging 1500 into 20 your load, right? So that much of capability having this battery, we can discharge it. Okay. Whereas a nickel metal hybrid batteries or the lead acid battery, they can provide you the load current at best is at 2.2 C or the 1 C. Okay. The operating temperature. So as I told you, inside the vehicle, when you are keeping the battery, this battery is going to entirely pack, right? So there will be no airflow inside because of we are not allowing to flow any air or water, which maybe cause the damage of the battery, right? So overall, it's going to be packed. Time at discharging time, there is heat will be generated inside the battery, right? So we need to check that how much your battery can withstand the temperature. So this is only during the discharging. So minus 40 to 60 degrees centigrade it can be capable. Okay, the maintenance requirement. So as I told you, if you are not using any battery for a long time, there may be some solids are forming on the electrodes, positive, negative, right? So that's why 3 to 6 months for the lead acid batteries and nickel cadmium metal hybrid from 2 months to 3 months. With the lithium polymer batteries, we don't require this maintenance, right? With its packing system. But compared to the cost, so lead acid batteries are very cheap for $25 nearly for 6 volts, whereas other is going to be changing. Okay, 2.7 volts. Okay. And the cost per cycle is nothing but a one-time charging or discharging is nearly $0.04 in our India if you're converting. So it may be the 2 to 3 rupees. Okay. So these are the some uses, commercial uses years. So the nickel cadmium batteries started in the 1950 onwards. So 1990 metal hybrid batteries are introduced. The lead acid batteries are introduced in the 1970 and 19 onwards. So lithium ion batteries are there. Inside the lithium ion, lithium different types of polymer batteries has came from 1919 onwards. This lithium polymer batteries are available in the market. Right? Due to the environmental constraints, so nickel cadmium battery, nickel metal hybrid batteries, we are not using inside the vehicles as of now. We are using the lithium polymer batteries or the and lead acid batteries only inside the vehicles. So these are some future batteries which those who are doing research are interested in the research. They can look into this kind of batteries. So future lithium batteries are like we can increase its capacity by changing these chemical reactions or electrodes or dielectric materials. So there, zinc air battery and lithium sulfide batteries, lithium air batteries. So these are some are development, some are under research. Which capacity is going to be compared to the current available batteries? This battery capacity is very high. Okay. So one small example I have given here. So for to calculate how to we calculate and compare the same company but a different polymer batteries, lithium polymer batteries. You can check here. I took the three different lithium batteries: lithium, nickel, manganese, cobalt dioxide, lithium ion ferrophosphate, lithium ion titanate batteries. Okay. So these are the cell voltages of each cells, different chemistry: 3.6, 3.2, and 2.2. Right. So if you take the let the battery require the 360 volts of rated voltage and 14 cells for each module. So here module is nothing but the combination of series and parallel of some cells we are connecting, and the number of modules became into the battery. I will show you that difference between cells, modules, and the battery pack how you will make. Then how many cells need to connect in series and how many modules are required. Okay. So if you have pack voltage is 360 volts we required, and the number of modules per 14 is, if you can divide it, then you will get the directly nearly 100, right? Then 100 divided by we have 14 modules so if which required, so 100 into you can get easily 8, right? Whereas the number of modules if we are going for the lithium titanate, because the voltage rating is less, so we require number of modules more and more number of cells. Okay, you can see one more example, you'll get clear idea here. So let the battery voltage required 360 volts and 120 ampere per hour and 12 cells per module, right? And how many cells we need to connect in the parallel and how many modules are required. Okay, right. The energy capacity of the battery depends on the motor continuous and pack current requirement. So this H value, so how much of power we are going to reducing, it is going to be, it's not constant during a load condition, but here he said that we require this much of current, right? The same capacity if you are taking is, so whereas a lithium ion battery, phosphate batteries we require the uh, so number of cells is only 6 cells we required in the parallel to meet the current requirements. Okay. So we need to some mathematical calculations to match the series and parallel combinations. So that's why. Okay, I will go a bit fast because we have only 15 minutes left. So other parameter is the energy cell or power cells. So what is the difference between the energy cells and power cells? Yes. So energy cells is a for high range. That means for long usage. The power delivery per for discharge capacity. You can see here the discharge capacity is milliampere. It can deliver the 500 of power with 1C rating. Okay. Here we can observe here with 1C rating, it's maybe zero point 0.2 or 1C, 2C rating also. It can the power cell can deliver to only 200 milliampere hours only. Okay, it's 1C you can observe here. That means for with less time, more amount of power can deliver by the energy cells. Okay, whereas move from the 100 to 200 kilometer per hour within a some fraction of 2-3 seconds, right? In the case we require the huge amount of power with less time, there they will use the power cells. But we require the more mileage. That means I want to travel for some 100 kilometer, 200 kilometer, but we don't require 200 kilometer per hour speed. We require some 50 to 60 kilometer hour, right? But I require more distance to travel. So in that case, we'll use the high energy cells. Okay, that is depends on the C rating. If you're discharging with that 1C, 2C means more amount of power I'm consuming with less amount of time, right? So in this way, we are with the C rating will be defined. So overall, whatever we learned, different selection of the batteries. So for each and every cells, they will provide the one data sheet. So in the data sheet, they will specify this kind of specifications, like what is the nominal capacity, how much of power it can be capable to deliver, and what is the voltage rating, minimum voltage, maximum, average, and maximum. Okay. So recommended charging voltage. So for each cell, if you are connecting based upon series and parallel combination, the overall charging voltage is going to vary. Per this is for per cell. Okay. 4.1 is recommended to charge for the high life. Okay. Energy density is 170 watt hours per kg. And charging they can use for continuous two charge. Suppose it is a 44 ampere hour, so you can use 88 ampere hours of current supply to charge this battery. The best performance. If it's a pulse charge, means continuous charging, discharging, you can use up to the 44 into 4 times. Okay. During discharging, you can use up to the into 3 times you can able to discharge. If more than if you discharge, the battery is going to be die very fast. Okay. If it is a pulse, then you can discharge 10 times of this one. That means 440 amperes per hour it can capable to discharge the battery. Okay. The operating temperature also they will specify like this. So minus 20 to 50 degrees they can during a discharging, during a charging 0 to 45 degrees. Okay. The number of life cycles. That means we can charge or discharge a battery 6,000 times up to. It depends on your utilization. Suppose you are charging for only 50% and then discharging. That means 0.5 cycle is also consumed. Right? They will specify the dimensions and weight. So this is overall battery pack how you are making from cell level to the battery pack. So in the market as of now, there is a 4 types of cells are available. This is called the button cells. This kind of cells maybe you can observe in your watches. Okay, in cell phone, normal hand watches, they will use this kind of buttons, small toys. Other one is called the cylindrical type. Okay, in the cylindrical, each and in cylindrical and prismatic or pouch type, the material will be same. One negative electrode, one separator, one positive. Okay, the casing is only going to be changing. Different material they will use. Okay, they will wrap into the circular and making as a cylindrical cells. And prismatic cells they will use the one small box. Okay, inside the box the same material they are going to be folding inside. Okay, in pouch type they will like a positive here. Here is a positive, here is a negative electrode, and they will make it as a wraps. Okay, they will make positive on electrical load. So by connecting a number of series and parallel, they will make a one module. Okay, and this kind of number of modules they are going to connecting in series and parallel to make a one battery pack. So this is called the from cell to module. If you see the any traction battery, so there is a this will be the general architecture. Okay, so there is upper cover. This is called aluminum or housing of the housing case upper shells. Okay, so which is going to be protecting from the mechanical support. And second one is below one will be about that the cast element lower housing with a module for each cooling pipes. So each and every module having a separate cooling pipes. Okay, these are cell modules. So different cells are connected into the different modules. So sorry, series and parallel combination. They are connected through electrical, and they will make into the pack. So this is a module casing. Okay. On above the module, there is a some again. There is some coolant pipes they will use to in order to send the coolant to uniquely, or we can say that all batteries need to be uniform cooling to flow. Okay. So the HV connections. So this HV connection is nothing but the output of the battery. So where you are connecting your load or charger, there is a to charge and the discharge the battery. So you will provide the HV connections. Okay. It's called the junction box. So and HV charging connections. These are the major parts in the any traction battery. If you go inside, okay. These are some top companies which are making the batteries in the world. So Catel, LG Energy, Panasonic, BYD, Samsung, AC. Right, right. So China, as I told you, Catel and the China, as I told you, Catel and the BYD, which are the China companies, which is share nearly the if you combine these two, 32 plus nearly 7, so 39% of the battery managed share itself from the China. Okay, to use for 1 day, 2 day, or maybe one cycle or two cycle, that to use for 1 day, 2 day, or maybe one cycle or two cycle, that can be also estimated by using some estimation algorithm. And cell balancing, the cell balancing is nothing but, so if you take the same company cell also, when you are charging the both the cells, the both are not going to charging at the same level. Some battery may be charged slowly, or some battery may be charged fastly, right? It is due to the internal characteristics or due to the maybe aging is nothing but when you are using your battery, if you can observe in your mobiles also, when you purchase a mobile in the during the initial days, its performance is very high. It will take maybe 1 hour to charge, and maybe you can utilize for 1 day fully example. But after 2 years, what happened? It will charge within half an hour. Instead of 1 hour, it will charge half an hour itself. Okay. Why? Because the internal the capacity of the battery is reduced. Now it's charged very fast. And if you are getting 1 day of charge, sorry, 1 day you can utilize the battery if it's 100% charging. After 2 years, within 3-4 hours, it's going to be discharged. Right. That means due to the its health is going to be reduced. And the inside the cells also, they have a 2C, 1C. There are different kinds of cell chemistries also they are manufacturing in the lithium battery. So that cells what happen? They may be imbalance. One charge will charge, one battery will charge very fast. One battery will discharge very fast. So we always need to make both are to be balanced. All the cells to be balanced. If you are not keeping the balance, what happen? Whichever the cell, suppose this cell, let us say these two cells are there. This cell is discharging very fast, right? So, but still this battery is not discharging. If we will go into deep discharge, this is going to be completely die. But still this battery having a capability of some 30-40%. Maybe I can explain more in detail in the next slide. So, so compared to the power limit, so how much of power it can be capable to deliver. Okay. Why we need BMS? So BMS will provide the mechanical suppose short circuiting protection. It will provide. This is called the mechanical damage. Also, it can be identified. Right, it's called a nail penetration. So if anything damage from heating in the vehicle or something, right, and if any fire or short circuiting happen, there may chances of the fire hazards. So that is also going to be estimated. We require to protect. And so this is called the completely deep discharge. You can say that well battery will completely die. Okay, because of any of this reason, maybe one cell is going to affect in the rest of the cells, then overall battery is going to be affecting. Okay. So there are some hazards which is internal or external problems. There is overcharging if you do, or short circuiting, or directly so is anything heating, or penetration from external if something heating to the vehicles, or the overheating or external short circuiting. Okay, this all may be causing the some battery to be failure. So to protect all these things, we require some battery management system. So this battery management system will estimate will measure your current, voltage, temperature, and communicate with the other systems, and it will say that okay, this your battery is heated this much, or your battery percentage is this much left, your battery has versus this much left. You need to replace the battery after 1 month or 1 day or after one charge, right? And when there is a battery is heating, the thermal management will be there, which is going to be providing the your coolant to your battery, or maybe the air coolant or liquid coolant, depends on that. Okay, the power optimizations, if consuming more power, so it will going to be reducing, or it is optimized by using the powers. Okay, and the different features are cell supervisory estimation, as I said, cell balancing, cell fault. This is all will be performed by the your battery management system. So the major components is cell monitoring, cell balancing, local control, and safety functions. So these are some functions which is going to perform by the battery, right? So the AF is nothing but analog front end. So where we are connecting your elements like positive and negative, that's called the analog front end. So this will be actual. We are measuring the battery voltage or current or temperatures that we are giving to the by using the converters like transducers, which convert in the electrical to thermal, like that, and to we are giving to those values to the your controllers in the digital form. Then there the estimation will be happen. Then we'll get our digital values like voltage value, current value, RSOC, health, how much is left, that we will get here inside. Okay, the BMS architecture will look like so inside. So battery pack will be there. The battery pack is connected through the one power distribution unit. Is consisting the main power supply, high voltage isolations, and the low power software will utilize. So low power software will utilize. I think we time is going to be complete. We'll go a bit fast. So this is overall architecture. So here we can say this little bit inside the battery communication systems and high power lines, charging point, discharging points, microcontroller, so AC, DC, motor control will be there. Okay. As I said, so different functions are there again in detail. So what are the component specifications? So BMS AFE materials. So they will specify like this: some main controllers, some company cores, and I have given some details. So what are the safety levels we need to measure? So estimation methods, as I said, so we have direct methods, so where we can measure directly, and bookkeeping methods, a Coulomb counting method, adaptive methods like Kalman filter or Stigma font, uncertain Kalman filter. Hybrid methods are the combination of any of these methods. We can say the hybrid methods. So HOH is, we can simple formula, if you get present capacity and the beginning of the life. So the passive balancing. So whichever having a complex algorithms also required. Complex algorithms also required. Okay, these are different categories of the active and passive cell balancing methods. So these are one of the method, we can say the fixed center register. So if suppose this cell having a low capacity, so rest of the two cells also going to be discharged until this is going to be equalized. Okay, whereas a passive balance, sorry, active balancing, so this energy is transferred into the third cell, and this cell also will transfer the energy to the third cell until these three are going to be equal. We are going to transferring energy, which is called switcher capacitor. Like this is a boost converter based, so same thing. So whichever cell having a low amount of energy, the rest of the cells are transferring the energy to the low amount of capacity cells. Okay, boost buck boost converter or the cup converter, we can use different methods. Okay, so different battery protection methods also available using the different charge optimizations. Okay, so the future is a wireless BMS. So without any connections, you can use the wireless BMS, and we require thermal management system. So each battery having its own optimal capacity ranges. So 10 to 30, 15 to 45 degrees, it's providing the optimal capacity. If temperature is very low, also the efficiency is decreased. If temperature is very high, also the voltage, current, and temperature have the all the cells and estimating all the different parameters: SOC, SOH, SOP. Opportunities in the job. These are different companies which are going to providing the job options. There are some references which I took. So if you have any questions, so let's take it very fast. You can unmute yourself. You can maybe